Hello, hello, and welcome to this video here. So, in this video, we are going to talk about multiple inheritance in C++ as well as in other programming languages. So, without further ado, let's get started. So, we have been doing inheritance for some time, and we have seen how we can inherit from one class. So, dog has inherited from animal here, for example. Or if you look at earlier, here also dog has inherited from animal. Here we have public derived, which is derived from base and protected and all that. We have seen such examples. Now we will derive from multiple classes. So that causes a problem, and I will go directly into that problem, which I'm going to tackle. And you would have figured that out by now that it is a diamond problem. So a diamond problem, how we can have is, suppose we have a class A and B inherits from class A, C inherits from class A, and D inherits from class B and C. So if you look at the inheritance diagram, then what it will look like is, what will happen is you have class A, and then from class A you inherit a class B, and this side also. So we have here class B and class C, and then from both of these we are inheriting class D. Okay, so this structure looks like a diamond, so that's why it's called a diamond problem. Now we'll see what is the problem. So we have all this inheritance. Class A has set A and get A. Set A sets the variable A data member, and int member get A returns that A. Now we create an object D and we call set A and we call get A. Now you can see the problem right away. Okay. So set A is found in multiple base class subobjects of type A. Now hint is member found by ambiguous name lookup. Get A is a problem. So the thing which is happening is we are having two copies of A in class D. So let's hit the terminal and we call it G++. Okay, we don't have. So we compile it, -vol -w errors -std is equal to C++26 pedantic, and we have multiple errors. So we have got the problem. Get A is ambiguous. It's the compilation issue. So one of the ways of resolving that problem is that you say you do scope resolution operator and you say that I want to go through B and this I want to go through C. Okay, and then we try to compile it. It works fine, and then we run this. Now you see the problem. A is created, then B is created, and then A is created again for C. Excuse me, and finally D is created. Okay, so you see the problem here. Okay, we went through B to set A and we went through C to get A. Wouldn't work. These are two different copies, so we need to get through B. Let's see the problem now. Now the problem is not there. We have proper values, but still there is another object of A inside D which has a different value of A. So every time you have to do scope resolution operator and you go through the proper copy of A. Not good, because now this basically means if we do that nonsense, this will mean that we are doing something like this. Okay, we have two separate paths, one through C and one through A. That is not what we desire. Okay, we want a single copy of A. So what we do is, the way to achieve that is we do virtual. Okay, and we do virtual here. Okay, now there will be only one copy of A. So now it is safe to access that A's object through any path. So works. Now what you can do is, you don't really need the scope resolution operator here. We don't. It doesn't matter what path you take anymore, because there is only one copy. If you want to be verbose, yes, you can do B colon or C colon, but double colon is name reservation operator in C++. So we compile this again and it works. It doesn't matter. Okay, there is only one copy of it. So that is how you do multiple inheritance in C++. So we quickly end with that. So let's now talk about something about multiple inheritance. I don't know if you know Java or not, but Java does not allow multiple inheritance. It has a mechanism called extending the base classes. So you can extend from multiple classes. Okay. And somehow it manages that. I don't know Java. I don't know the details. What happens when you extend like this? So I really don't know Java. It is a disgusting language for me. So C++ is kind of raw. It allows you to have all the power. Whatever you want to do, you are free to do. You want to have 2 copies of A, fine. C++ does not care. It is up to you. You want to, well, 4 copies or 8 copies, you can have that. Okay. C++ does not care. How we can have 4 and 8 copies is that you can have 8 such classes like B and C, and then another class will inherit from 8 classes. Of course, that will make the inheritance diagram like an ugly toad, but yeah, you can do that. Now, the question is, should we use multiple inheritance or not? You can, as long as, or rather, you should, as long as your inheritance diagram is not complex, okay? And if you have watched my composition and aggregation videos, then you would know that in C++ world, composition is preferred, okay? Because of 2 reasons. The object ownership is there in the class which embeds it, and the second is that your inheritance diagram is simple. Now, what problem can happen when we have complex inheritance diagrams? Suppose there is a big chain of inheritance from one object to another. If you want an example, you can look at the Java standard library inheritance diagram. You will go nuts. So what can happen is that suppose you are working in production and one of the exceptions came, and you looked at the class of that object which threw the exception. You see there is no exception there. So where could it be? It could be in one of the parent classes or grandparents. So you traverse the exception hierarchy all the time to trace the exception. Okay, this is where exception is coming from. All right, you can say that it will log the file name and all that, but even then it is problematic. I have faced it in production code. Not all the time you will have the direct file name and line numbers. It's problem. It's a big problem. There is reason that why people don't prefer inheritance in C++. Now, if you see that Java maintains that object overloading should not be done because programmers abuse that. That is James Gosling's opinion. Linus Torvalds says that I want to keep C++ programmers out because C++ programmers misuse C++. Staustrup says that there is a very tiny language or small or lean language inside C++ which wants to come out. Then you have massive Misra and Google coding standards. And these standards were quite useful prior to C++ 11. C++ 98 was nasty. There was no unique PTR, no shared PTR, and that kind of stuff was not there. There was not even R value. There was no move constructor. So you had to do all this kind of nonsense yourself. So Misra and Google coding standards helped us write proper code, and they are kind of relevant even now. Of course, they have changed. So when you're coding in C++, adhere to coding standards. Don't try to be clever. Your cleverness will be doom of your system. Someday, who will maintain your complex code will have very nice words for you. Okay? And God forbid if he's a psycho, he will trace you and hurt you for that garbage code you think was very powerful and complex, and you wrote it if you're proud of that. So the essence is that try to keep things simple and try to keep your inheritance diagram manageable. and above all, try to make use of composition. Okay, that is the key takeaway from the object oriented discussion in this. Okay, you don't have to deal with multiple inheritance, you don't deal with nonsense of virtual functions and all that. Okay, you don't need polymorphism to write code. C programmers can write code. We don't need polymorphism. Just use composition. Golden rule. Always use composition. Okay, and they don't try to use inheritance. There are languages, modern languages like Rust does not have inheritance. It doesn't stop you from coding. It is one of the most loved languages. Golang does not have inheritance as far as I know. Last I checked, it might have changed, but there is no inheritance in Golang. So it is not that object-oriented programming is the only way of doing with the multiple inheritance and complex inheritance diagrams like Java. You can do the same level of effective implementation by using things like composition in C++. So that would be my advice towards the design side of objects and classes, that keep it simple. So I think that's it. There is nothing more to say about this, and in the next video we will look at abstract base classes and how we can design interfaces in C++. Very interesting topic and very useful also. So we'll meet again on the fourth day from now, and we will have abstract base classes. So don't miss it. And if you have not watched my earlier videos on C++, make sure you watch them. There are some nuggets hidden here and there. So thanks a lot for watching the video, and keep learning, and I'll see you in the next one. Enjoy.